Hi friends, today we are discussing some important problems. So the problem is find the Laplace transform of sine square t. We know that sine square theta equal to means here sine square theta can be expressed in terms of cos. Why? Because there is no direct formulas for these kind of functions. So there is a formula for Laplace transform of sine at, Laplace transform of cos at, but there is no direct formula for Laplace transform of sine square t. So this square can be expressed, the power should be 1. So that's why sine square t can be written as 1 minus cos 2t by 2. So therefore sine square t equal to 1 minus cos 2t by 2. Now we have to find out Laplace transform of sine square t equal to Laplace transform of 1 minus cos 2t by 2. Here 1 by 2 is constant, right outside the operator. 1 by 2 Laplace transform of 1 minus cos 2t, and this is equal to 1 by 2 of Laplace transform of 1 minus, now we apply this Laplace transform into first term and a second term. So that's why here we written Laplace transform of 1 minus Laplace transform of cos 2t. This is equal to, we know that Laplace transform of 1 equal to 1 by s minus Laplace transform of cos at. This is in the form of Laplace transform of cos at. Laplace transform of cos at equal to s by s square plus a square. What is a here? A equal to 2 square. So finally Laplace transform of sine square t equal to 1 by this 2 is multiplying each and every term. So therefore 1 by 2s minus s by 2 of s square plus 4. This is the process of finding Laplace transform of sine square t. Similarly, we have to find out Laplace transform of cos square t, Laplace transform of sine square 2t, Laplace transform of cos square 2t. So these are the examples of these kind of problems. Now this is next example, Laplace transform of cos square 2t. There is no direct formula for Laplace transform of cos square 2t. So that's why first we have to written cos square 2t in terms of cos only. Since cos square t equal to 1 plus cos 2t by 2. Okay, what is theta? Here theta, this is theta. Coming to this problem, now therefore cos square 2t equal to 1 plus cos 2 of 2t. Why? Because here theta, this is called theta equal to 2t, all divided by 2, and this is equal to 1 plus cos 4t by 2. Cos square 2t equal to 1 plus cos 4t by 2. Now we have to find out Laplace transform of cos square 2t equal to. So in this Laplace, cos square 2t is replaced by 1 plus cos 4t by 2. Laplace transform of 1 plus cos 4t by 2. Here 1 by 2 is constant. Shift outside the operator. The remaining terms 1 plus cos 4t. Now we apply this operator each and every term. So therefore we get 1 by 2 of Laplace transform of 1 plus Laplace transform of cos 4t. And this is equal to 1 by 2 of, we know that Laplace transform of 1 equal to 1 by s plus Laplace transform of cos 80. This is in the form of Laplace transform of cos 80. So what is a here? 4. We know that Laplace transform of cos 80 equal to s by s square plus a square. What is a here? 4. 4 square. 1 by 2 of 1 by s plus s by s square plus 16. So therefore Laplace transform of cos square 2t equal to 1 by 2s. This 1 by 2 is multiplying each and every term. So therefore we get 1 by 2s plus s by 2 times of s square plus 16. This is the process of finding Laplace transform of cos square 2t. Yeah, this is one more example. Find the Laplace transform of sine power 3t. Similarly, there is no direct formulas for Laplace transform of sine power 3t. So this sine, we know that sine power 3t formula. So how to find the sine power 3t in terms of sine? Since sine 3t equal to 3 sine t minus 4 sine cube t. From this formula, we have to find out sine power 3 theta value in terms of sine theta. And this is implies, we shift this is into this side and this is into this side. 4 sine cube theta equal to 3 sine theta minus 3 sine theta minus sine 3 theta. And this is implies sine cube theta equal to 1 by 4 of 3 sine theta minus sine 3 theta. Therefore, sine cube t equal to 1 by 4. So in this formula, theta is replaced by t. Why? Because the given question is in terms of t. 3 sine t minus sine 3t. Now, Laplace transform of sine cube t equal to, so here this sine cube t is replaced by 1 by 4 3 sine t minus sine 3t. 1 by 4 3 sine t minus sine 3t. Here 1 by 4 is constant. We shift outside the operator. So therefore we get Laplace transform of 3 sine t minus Laplace transform of sine 3t. We have to find out Laplace transform of 3 sine t value and Laplace transform of sine 3t value. and this is equal to 1 by 4 of 3 into Laplace transform of sine 3t. Now since this 3 is constant, we shift outside the operator. So that's why we written 3 Laplace transform of sine 3t minus Laplace transform of sine 3t. Now since Laplace transform of sine at equal to a by s square plus a square. Now we apply this formula for first term and second term. This is only sine t. So therefore Laplace transform of sine power 3t equal to 1 by 4 3. This is Laplace transform of sine t. What is a here? A equal to 1. So that's why 1 by s square plus 1 square minus Laplace transform of sine 3t. What is a here? A equal to 3. So therefore 3 by s square plus 3 square. 1 by 4 of 3 by s square plus 1 minus 3 by s square plus 9. This is Laplace transform of sine cube t. Now we discuss Laplace transform of cos cube t. Similarly, there is no direct formula for finding Laplace transform of cos power t. This cos power 3t can be converted into only in terms of cos. Now since cos 3 theta equal to 4 cos cube theta minus 3 cos theta. Already we know that this formula. So from this formula, cos cube theta can be expressed in terms of cos 3 theta and cos theta. And this is implies, we shift this is into this side. So therefore 4 cos cube theta equal to cos 3 theta plus 3 cos theta implies cos cube theta equal to, we shift this 4 into right side. So therefore 1 by 4 of cos 3 theta plus 3 cos theta. So therefore cos cube t equal to, why? Because the given question is in terms of t. Cos cube t equal to 1 by 4 cos 3t plus 3 cos t. Now we have to find out Laplace transform of cos cube t. So now Laplace transform of cos cube t equal to, so this cos cube t is replaced by this right hand side value. So therefore we get Laplace transform of 1 by 4 cos 3t plus 3 cos t. 1 by 4 is constant. We shift outside the operator. So therefore Laplace transform of cos 3t plus 3 into Laplace transform of cos t. Okay, we apply this Laplace operator into cos 3t, we getting Laplace transform of cos 3t, and similarly we apply this operator into second term, but where 3 is constant, so that's why we return outside the operator. Then we return Laplace transform of cos t. We have to find out Laplace transform of right hand side values. Here this is Laplace transform of cos 3t and this is Laplace transform of cos t. This is in the form of, now since Laplace transform of cos at, we know that Laplace transform of cos at, this is equal to s by s square plus a square. By using this formula, we have to find out Laplace transform of cos 3t. What is a here? A equal to 3. So therefore, s by s square plus 3 square plus 3 into the second function. This is Laplace transform of cos t. What is a here? A equal to 1. So therefore, Laplace transform of cos at equal to s by s square plus 1 square. Now since a equal to 1 here, and this is equal to 1 by 4 of s by s square plus 9 plus 3s by s square plus 1. So this is the Laplace transform of cos cube t. So this is a very important type of question in exam point of view. Now we will see one or two examples based on this problem. Find Laplace transform of cos cube 2t. Find Laplace transform of cos cube 2t. Find Laplace transform of sin cube 2t. Find Laplace transform of sin cube 3t. So these are the similar problems based on this problem.